solve math?
Many!
Your live homework help starts now. Welcome to Count on Us.
What is the length from the entrance to the giant wheel?
All right, so let's add 3 here and see what happens.
First, measure first. I need you to double check yourself. So the second equation for solve perimeter is?
2 times length plus 2 times width.
Good afternoon. Welcome to Count on Us. I'm Miss Shirey.
I'm Mr. G.
And we are here to help you with your homework this afternoon. I hope everyone had a great day. Fun-filled math day. Right, Mr. G?
Mine was filled with woods.
That's right, because you were at Camp Schmidt. But that's
Camp
okay.
Schmidt.
I was at school, and we were doing math, and it was awesome.
Wonderful, wonderful.
So before we go any further, we have some challenges for today we'd like to show you. Mr. G, would you like to explain our first challenge?
Okay, the first one we have is a word problem. The number you're looking for contains 3 digits. The first and second digits equal the third digit, so you have to add them together. The first, second, and third digits equals 12. The 3-digit number is greater than 200. Is the number 624, 347, 156, or 246? You have to eliminate all the possibilities and come up with the right answer.
Use the clues kind of problem.
That's
Very
a
nice.
meaty one. I like that problem.
Yes, yes. And of course we have our Challenge 24.
Challenge 24.
Here they are, 4 cards today. Take some notes, write these down, work on them while we're working on the show, and call us with your answer. Card A, 8861.
Card B, 6758.
Card C, 7331.
And card D, 9248.
Make sure you know that's a 9 because it is colored in red, so that would be a 9. Of course, this is the hardest one, the last 3 here, because they have 2 dots instead of the 1 dot.
Don't tell them it's hard.
But there's always more than one way to solve
There's no such
it.
thing as hard.
It's more challenging.
There
It's
you
more
go.
challenging, Mr. G.
Don't
So
tell me that.
these 3 are definitely more challenging, but I know you can solve them. In fact, I know you can solve them more than one way because there are many ways to figure out these problems.
I just solved 3 of them.
What?
Woo!
I'm so impressed with you today. Well, I'm sure I'm going to solve it 3 other different ways.
Okay.
Okay.
You can call us at 301-772-0080. We are here waiting for your homework questions.
Absolutely. But in the meantime, we have lots of math, little mini lessons to show you for today. So what have you been working on, Mr. G?
Long division.
Oh, long division. It's so long.
Isn't it special? We've been doing it with base 10 blocks because when it comes time to show and prove, you have to have a visual representation.
Oh, you sure do.
So
Okay.
we've been talking about that a lot with
So
everyone.
would you like to show me what you've been working on?
Do we have some base 10 blocks?
I can find some for you. But
Do I
can
have
you
to draw them?
You can draw them. I don't know if we'll have
my
enough because I know your
goodness.
problems are more challenging, so you might need some,
you know
some
what?
more blocks than what we have.
I'm still outside, so let's see.
Work
Can I
it
go
out.
easy?
Work it
Can
out.
I go easy now?
Go easy.
Can I go
Start easy for us.
Okay, let's do, let's see, 224
Divided by.
4.
Okay.
So what that's saying is if I have 224 starbursts that I happen to love,
Okay.
and it's myself and 3 other friends, and I
Right.
share them all evenly because that's all division is sharing, how much will each person get?
Oh, okay. Well, I don't really, your number's really big, and I don't
It's really
have
big.
enough.
Do I need to make a smaller
No,
number?
because you know what? You can't go around the whole world carrying your base 10 blocks, right? You have to know how to
this is
represent them
true.
with a picture.
This
so
is
that's
true.
okay.
Okay. So, so you're suggesting I make a picture?
I'm suggesting you do
Okay.
because I don't know. I
I
don't know
think I
about you,
wrote
but I
too
don't carry these
big.
around in my pocket.
Okay.
You have to know how to represent them.
So I have 200, 10,
Okay.
20, and 1, 2, 3, 4. All right. broke them up nice and neatly into 2 groups there. So here's my hundreds.
Okay.
Here's my tens. Here's my ones.
Okay, so you're saying that your square here, represents our hundreds.
Exactly.
And your little stick represents our 10 rods.
Exactly.
Okay, and of course, your little dots represent our ones cubes.
Exactly. You are on it.
Thanks.
You are on it. What a team member here.
But this is hard, Mr. G, because we don't have 400.
It's challenging, but it's not hard.
Oh, but I don't see 4 of the hundreds. How are we going to share them?
So I have 200s, right?
Right.
So the first question we have to ask is, can we share 200s with 4 people?
No, it'd be kind of tricky. We'd have
So
to show it in another way.
200 itself.
We could.
We could,
Yeah.
but the way it is we just have 200s here.
We'd
2
have to give it another
individual
name.
hundreds. We would have to change those things up.
We would.
So if I have my 4 groups here, 1, 2, 3, 4.
Right.
Could I take these 200s and put them into my 4 groups? That's not going to work.
No, not the way they look now.
Exactly. So what I have to do is I have to turn each of these 100s into 10 10s.
Oh, I see it. Look on our little hundreds.
Right.
Oh, so you're saying it's like I would take scissors and cut that into
Actually,
10.
if you give me one of those 10s,
There you go.
bam.
Oh,
It
I
fits
see.
perfectly.
So you could just cut it apart, which we
Right.
don't want to destroy
10
our
slices.
hundreds.
Bloop, 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 bloop.
Oh, so each one of these is 10 of those.
Exactly.
Oh,
So
I get it now.
this will
Okay.
give me 10. The second one will give me 10. Now I have 20 10s.
Okay,
And
and
I already
then-
have 2 10s.
Ta-da, right
so
here.
now I can share 22 10s now.
Oh, now I get it.
Now,
Okay.
what some people do is they put a 0 here first because they say, well, I can't share 200s.
Right.
So some people do that because those 200s can't be shared.
Okay.
And then those hundreds get turned or regrouped into 10s.
Oh,
and now this is 22 10s.
Okay.
So I can share 22 10s with 4 groups.
I sure can.
So if I did that evenly, I said 1 for you, 1 for you, 1 for you, 1 for you.
You know what, Mr. G, I want to take a moment and I want to give a shout out to Miss Shepard's class. Shout out to Miss Shepard's class today. You're doing a
Miss
great
Shepard's
job on your math.
class.
We just want to give a shout out to
Woo!
you today. We know you're working hard. So thanks for watching the show and keep on working on your math homework while we're talking about our long division.
Okay. So
All
keep
right.
on keeping on. All right, so here I have 22 10s here, so I'm
Right.
just sharing them
Share them.
evenly.
Share them.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. What do I have there?
That's
17, 18, 19, 20.
20.
So-
Okay. So I can share 20 of them evenly.
You see how I put that little diagonal
see.
there? So
Like
now
tally
that's
marks?
that's tally
Oh, I
marks.
like that,
So
okay.
I have 5,
Right.
10, 15, 20.
Right, but
and
there
then
were
I
two
have
extras that
Those
you
2
could-
extra I
Right.
can't share evenly
No.
as 10s.
What do we do with
So
those?
the question is, how many of the 10s did I give away?
20.
I gave away 20 10s. How many 10s were left over?
2.
2. And how many 10s did each group get?
Each
5
group
here,
got-
5 here, 5 here, 5 here. So each group got 5.
Everybody got 5. Okay.
I shared out 20,
Right.
and 2 were left over
Here,
that I
here's the
could not
2.
share.
That's
So
right.
now
Okay.
I have to regroup again.
What?
Yes.
Okay, I'm good at
because
regrouping. I can do this.
I have 20 there,
Right.
but the way those 20 are, they can't be shared that
Right.
way.
Well,
but
there's
they
2
can be
chances.
shared.
If you cut them all apart, just
If I
like we
cut them
did the
all apart
hundreds.
again, and I turn them into
20 of the
21s.
ones.
Exactly.
And then I have 4 of the extra ones.
Exactly.
So now I have 24 ones.
24 ones.
Oh, okay.
Got it?
So, but I don't see the number 24 down here. I
You
don't get it.
because
no.
now I'm going to bring that down now because now I'm going to turn all of these into ones.
Okay, so 24 ones.
Now I have 24 ones.
Now I could share them. Now I don't have 24 ones
Exactly.
today. I don't know. Maybe somebody got hungry and they ate them. I don't
think
have them.
so?
I don't know.
that
It wouldn't-
happens sometimes.
It wouldn't be
especially
a
if you-
tasty snack.
Yeah.
I don't know.
So if I just take my ones now,
Okay.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24.
Oh, that divides evenly.
That works out perfectly. I have nothing left over.
Right, but how many ones in each group?
Each group got 1, 2, 3, 4, 5, 6.
Oh, okay.
And it just so happens that 4 times 6 is 24.
Oh, okay. That isn't so bad. That's not so bad.
But we're still not done.
What? Why not?
Always, always, always have to check our work.
Okay. What do you mean by check your work? I
Well-
checked it. Here, look. Give me a big marker. Look, I'm going to check your work. Check. You did a great job, Mr. G. Ha, ha, ha. Why are you laughing at me?
Because I want proof. I
want
want
proof?
proof that this works out. So
How did you do that?
I can use the inverse operation of division.
Oh, you mean multiplication?
I can multiply. So
Okay.
now I can take my quotient and
Okay.
multiply it by my divisor.
So 56 times
So
4.
now I can do 56 times 4.
Okay.
So now we have 4 times 6 is 24.
Okay.
4 is there. That 2 goes in the tens place. And this is one of my challenges. I always tell people, now this is not 4 times 5. Because everybody gets real comfortable with that. But then we lose the importance of place value when we do that. So that's really 4 times 50,
Okay.
which is 4 50s is 200.
Right. Plus 2
Not
more.
20. Plus 2 more tens.
Okay.
So that's 200 plus 20 is 220. And that's why when we write it, it fits right in the right place. 200, that 2 goes in the hundreds place. And the other 20, that
Right, went in
2
the tens.
goes in the tens place.
Oh, I see. Okay.
So this should look like this.
Okay, and it does.
Ta-da!
We did it right. Great.
220.
I don't multiply like this. Can I show you how I multiply?
You multiply differently?
Yeah, I
You
multiply.
can't multiply
Can I have
differently.
your red marker?
Oh my
You're
goodness.
hogging
you
the
have a different-
marker.
you have-
He's hogging the markers.
I'm hogging the marker.
Okay.
I
Look,
apologize.
if you do 56 times 4, I'm going to do your same problem, but
Okay.
this time I want to show you my way. So
Let me see.
56 times 4. That's 56 groups of 4, right?
Okay.
Okay, but I don't do it that way because 56 is really 50 plus 6. So if I
Oh, you
multiply
broke the
each
number up.
one, yes, this is how I multiply. 50 times 4 and 6 times 4. So what I'm doing is I take them apart and then I put them all back together.
Gotcha.
So now I see what you're talking about. 4 times 50. 4 times 0 is 0. 4 times 5 is 20.
Here's the 200.
And then I know my facts. 6 times 4 is 24. So now I'm going to put them all back together.
Okay.
So 200. I know 200 plus 24 is 224 because I know place value.
Oh, so it seems like
It's so much
they're very
easier.
similar. It's
But I
kinda
think
like,
my way's easier.
That kind of like puts it together, all together.
Yeah. Mine's
That
like,
breaks it up because you broke the number 50 up, 56 into
I like
2.
friendly numbers like
Okay.
50. It's much easier
Right,
that
those
way.
10 numbers. You call them friendly numbers?
Friendly numbers.
Yeah, they are pretty friendly.
Okay.
Because 49 would be a little challenging.
Yeah, 49 is not very friendly. No. Well,
Cool.
that's great. Now we can do long division.
Woo!
Well, we've been doing a whole bunch of stuff in 2nd grade. Can I show you some of my stuff from 2nd grade?
Absolutely.
Okay, can you help me
I like
erase?
2nd grade.
2nd grade is awesome. We were using tens and ones today too. We were doing place value blocks, but we were subtracting. Subtracting with regrouping.
Yeah, that regrouping can be a little challenging.
It is,
I think the base 10 blocks really help a lot.
They do, but my kids are so smart. They don't mind. So we were doing problems like this today. 54 minus 28.
Gotcha.
And I teach my kids a little saying. It goes like this. More on the top, no need to stop. More on the floor, go next door.
I like that. I have to learn that song.
Yeah, it's really
There's a little
great.
bounce to it.
Now, of course, we use our place value blocks, and we're always doing the right mathematical way. But sometimes you just need a catchy little tune to help you out, help you remember.
Okay. I
So
like
you
catchy
look in the
little
ones column, and if there's more on the top, then you don't need to stop. You just subtract. But if there's more on the floor, meaning this number is bigger, then you need to go next door. And you need to
On the
regroup.
floor, then go next door.
See how that works?
Okay.
Yeah, it's kind of catchy. All right, so there's more on the floor. Did you notice that, Mr. G?
I see.
8
I
is
see.
bigger than 4. And I told
Well,
my
why can't
kids,
you just say, okay, 8 minus 4 is 4?
because you can't.
Why not?
Because I'll show you why. Look, 1, 2, 3, 4, 5. 5 tens, that's my 50. and 4 ones. This is why. Let me prove it to you.
Please.
Now, if I have
Like
4
proof.
ones, Mr. G, I can't give you 8 ones. I don't have 8 ones to give you.
Oh, there's only 4 there.
Right.
And you can't change it because
I
that's
can't
what you're
change it.
taking from.
I can change it, but I can't give you 8 ones right now.
Right,
I have to
got you.
exchange or regroup. So I take a 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I make it 10 ones. I just cut them up. Now I have these 10 and I have those 4. Now I can give you 8. Now I have enough.
Oh, but you have 4 10s now instead of 5 because you changed one of the 10s for
Can I see
10
your red
ones.
marker, please? And I'll show you how. So now what I have, now I don't see 5 10s and 4 1s anymore.
Right,
What do you
absolutely.
see?
I see 4 10s
You see
and
4 10s
and 14 ones.
and 14 ones. So you just tell me what the picture looks like now.
Ah.
So now I can subtract 14 minus 8. 1, 2, 3, 4, 5, 6, 7, 8.
Why'd you write the line through them?
Because I'm subtracting them. I'm taking them away,
Oh,
Mr.
you're
G.
taking them away.
14 minus 8, I'm getting rid of them. 14 minus 8 is 6.
Let me check.
1.
1, 2, 3, 4, 5, 6. Okay.
Uh-huh.
6.
And now
okay.
I still have to subtract my 10s. So 4 10s minus 2 10s is...
2 10s left over. Because I was thinking 5 minus 2 is 3.
No,
doesn't
I
work.
don't have 5 10s left
Right,
anymore.
right.
You need to pay
right.
attention,
That's
Mr. G.
I got it.
But I think we have a caller.
It's been a long day.
I know. We have a caller.
Caller?
Is it Felicia? Hello?
Hello?
Hello, is this Felicia?
Yes.
Hi, Felicia. Welcome
Hi,
to Count on
Felicia.
Us. How are you today?
Huh? Good.
Great. And what school are you calling from?
Cherokee Lane Elementary School.
Oh,
Cherokee
excellent.
Lane.
Cherokee Lane. And what grade are you in?
5th.
5th grade. Excellent. And how can we help you today?
I'm adding fractions with unlike denominators.
Oh, unlike denominators? Oh, they're so unfriendly. But that's okay. Mr. G can help you today.
We can change them.
We can. What problem are you working on?
2 and 1/10 plus 3 and 2/5.
Okay, Felicia, you need to turn your television down and listen to us on the phone.
Okay.
Because we can hear ourselves.
And when you finish doing
Okay.
that, tell me the problem again so I can write it down.
2 and 1/10 plus 3 and 2/5.
Okay. Do we have fraction bars over there that I can use?
Oh, we might have a few. Let me check it out. I don't think we have enough for the whole numbers, but I'm sure we do for the fractions.
Okay, Felicia, let's start with
Yes?
you telling me what you do know about when you have fractions and they don't have the same denominator, unlike denominators.
When you have unlike denominators, if you have an answer and they're both even numbers or odd numbers, or if the numerator is greater than the denominator, you have to simplify.
Okay. So exactly what would you be simplifying here? Can you identify what you would simplify? Do we have fifths in here?
What do you mean by simplify, Felicia?
You have to change. You have the numbers.
The numbers, which numbers?
The whole number and the numerator. The denominator always stays the same.
Okay, we need to make sure that the denominators are the same. So are our denominators the same?
Yep.
Are they the same right now? These are our denominators, a 10th and a 5th. Are those numbers the same?
Can you repeat that?
So you told me the denominators have to be the same. And right now I see two different denominators.
No, like when you find out your answer, your denominator has to be let's say when you simplify, like if you have to simplify and your numerator is 25 and your whole number is 5, the only numbers that can change will be the denominator and the one that can change is the numerator and the whole number.
Okay, so our denominator has to stay the same. That's what you're saying.
Yeah.
Okay, well, we have to make the denominators be the same. How can we do that?
We can see if 5 can go into 10, and if 5 can go into 5, and you have to see if 10 could go into 5. So that's not possible. So you have to multiply 5 and 10.
Multiply 5 times 10. We could do that, but I think that's gonna take you a little while longer. One of these denominators we don't need to change.
Okay, so Felicia, you're saying that you have to simplify. But before we can get to the part of simplifying, did your teacher talk about greatest common factor?
Did my teacher talk about what?
The greatest common factor.
I think she did.
Okay, so what do 10 and 5 have in common?
They both have 20.
I'm sorry, I'm wrong here. We're talking about the least common multiple.
Right, when you count by these numbers, what's the first multiple that they have in common?
10.
10.
10,
So
right.
5 times tables is 5, 10, 15, 20. 10 times tables is 10, 20. So the first number that they have in common is 10, correct?
Yes.
So that means that we can take the fifths and we can turn them into tenths. So what happens is we have 2 fifths here, right? We can turn them, each of these fifths, into tenths. So here's my tenths, right? I can switch these because they both share tenths. I can turn each of these fifths into 2 tenths. So that's what you're actually doing when you find the least common multiple. So now these fifths are broken up into 2 pieces, and that will give me tenths when I do that. So if I have 2 fifths and I break each of them up into 2 pieces, I wind up with 4 tenths. 1, 2 here, and 1, 2 here. So this is really equal to 1 tenth, 1 tenth, 1 tenth, 1 tenth. That gives me 4 tenths. So now I've turned them into the same kind. You follow?
Yes.
So now I have 4 tenths and not 2 fifths. And I can take now my 4 tenths with my 1 tenth and turn it into what?
Can you repeat that?
I have my 1 tenth, and I'm going to add it to my 4 tenths, and what's my answer going to be?
Add it to your what?
1 tenth plus 4 tenths.
You change the 2 fifths into 4 tenths. Now the denominators look the same.
We don't have fifths anymore, we have tenths, and we have 4 of them. So 1 tenth plus 4 tenths is what?
1 tenth plus 4 tenths would be 5 tenths?
Absolutely. So
Good
now
job.
we have 5 tenths. And 2 whole plus 3 whole equals what?
Can you repeat that again?
2 whole plus 3 whole equals how much?
You said 3 whole plus 3 whole?
2 whole plus 3 whole.
5 whole?
5 whole.
That's good. Great.
Now you were saying something before about simplifying. Here's where the simplifying part comes in. And if I have 5 of these tenths, simplifying them means how can I take these little pieces and make 1 piece, or the least amount of pieces possible. So now, can I divide both of these numbers by the same number to get the least amount of pieces possible? So this is the time where you use the greatest common factor. What's the factor that both 5 and 10 share?
They both share, I don't think that they share one.
They do. In other words...
Are you asking for the multiples, or...?
No, the factors. In other words, what two numbers multiply together equal 5?
5 and 1.
1 times 5, which means 5 is what kind of number?
5 is an odd number.
It's odd, but it's also a prime number, which means it only has 1 in itself as factors, right?
Yes.
But 10 is a little different. 10 has 1 times 10, and it also has what?
10 times 10 is 100.
No, 1 times 10.
9 times 10?
1.
Oh, that would be 10.
Okay, and what other factors equal 10?
2 times 5
There you
and
go.
1 times 5.
2 times 5. Now, what's the greatest factor that you have on both sides?
The greatest factor?
Yes. On both sides.
I think that it is...
Look at them.
5.
Are you looking at the TV while I'm working this out?
Yeah.
Okay, so I have 1 and 5 for 5. I have 1, 10, 2, and 5 for 10. Which do they share that's the greatest?
Can you... 10?
Is there a 10 on this side?
No.
So what number is on both sides?
The 5?
The 5. 1 and 5 on both sides, but we want the greatest that's on both sides, and that's 5. So what that means is I can divide by 5. In other words, what's the least amount of pieces that I can turn that 5/10 into? So 5 divided by 5 is 1, and 10 divided by 5 is 2. Now watch this.
2.
What that tells me is that this 1/2 is the same as 5/10. So instead of having 5 pieces, I have 1 piece. You see that?
Yeah.
They are equivalent. So when you're simplifying, what you're asking is, can I turn this into the least amount of pieces possible? Does that help?
Huh?
Does that help you?
Yes.
Okay, you're going to have to practice those to get real familiar with it.
Yeah,
okay?
that just takes practice. All right, Felicia, thank you so much for calling. Would you like to try one of our challenges?
Yes.
Okay. Which
Good.
challenge would you like? The challenge 24?
A.
The card A? Okay,
Yes.
card A is... I don't think that was card A. Wait a minute. What happened to our cards? That's the wrong card. Oh, I have it over here. Oh, no. I'm looking at the wrong card. You're right. 8861. Was that the one, Felicia?
What did you say?
Was it this card, 8861?
Yes.
Okay, 8861. We're going to write those numbers down. And you can tell.
Can I call back after I solve the problem?
Absolutely, absolutely. So write these numbers down, 8861. All the viewers out there, you can make sure you copy that down. In addition to some of our other cards here, okay? Card B is 6785. Card C is 7331. Card D is 9284.
And we have to put Felicia in our treasure chest.
Absolutely. Thank you for calling, Felicia. And when you get the answer to that problem, call us back. All right, right now you're in our treasure chest, and you are eligible for our prize today. Okay?
Woo!
It might be break time.
Is it break time? It's break time. It's break time.
I think
Go
it is
have a
break
snack
time.
and come right back. It's break time.
I
It's
know.
break time.
Come right back,
Go
though.
have a
Okay, we'll be
snack
back in
and
a
come
few
right
minutes.
back.
So we'll
Like
keep
my song?
working, and you keep working, and we'll see you in a bit.
You like my song?
I liked it. It was
Thank
good.
you. Thank you.
Hello, my name is Jessica and I attend James Ryder Randall Elementary School. I am in the 5th grade. Today, the math problem is, during some months, Earth revolves around the sun in 30 days. How many seconds is this? Well, there's 24 hours in one day. So in order to find the hours in 30 days, I must multiply 30 times 24, which equals 720 hours. In order to find out how many minutes are in 720 hours, I have to multiply 720 times 60 because 60 minutes equal 1 hour. And that equals 43,200 minutes. Next, in order to find out how many seconds are in 43,200 minutes, I must multiply 43,200 times 60, because 60 seconds equal 1 minute. And that equals 2,592,000 seconds. So 30 days equal 2,592,000 seconds. Woo! That was a lot of seconds. I hope you found the solution to your problem easy to follow. This is Jessica from Counting Us. Bye. See you next time.
Hey you, yeah you, stay right there, I gotta tell you something. I bet you know someone with type 2 diabetes. Guaranteed, you know why? Because 1 out of every 3 little kids is gonna develop diabetes in their lifetime. That is can lead to heart problems, strokes, and even blindness. I'm John Sally, and I'm telling you, it ain't gotta be that way. Now you can up your defenses by eating more fruits and vegetables, having more vegetarian and vegan meals. These steps can be the power plays to protect you and your family against the risk of diabetes. To learn more, go to blockdiabetes.org. Okay.
He was so inspiring.
He took chances.
He was so moving.
He lived daringly.
Martin Luther King Jr. was a man of service, and his day shall be a day of service.
He inspired us in words, but he led us in deeds. To honor him, let's do the same. Go to mlkday.gov and find out how to volunteer on Martin Luther King Day and beyond. This message is brought to you by the Corporation for National and Community.
Okay, guys, ready? Here we go. Let's smile and brush our teeth twice a day, every day. Let's smile and floss our teeth once a day, every day. Let's keep that smile a happy place on your face with good nutrition and dental visits. Let's smile. Let's smile. Let's smile. Let's smile.
The elementary edition of Count on Us. I'm Miss Shirey.
Mr. G, and the place to be.
That's right. I hope you've been hanging strong, keeping in the program with us, and we are back to help you with your homework today. Today.
It's
Yes.
Monday, beginning of the
Monday.
week.
It is. I love the beginning of the week.
Almost
We
time
have
to gobble,
so
gobble.
many things to work on. We are going to go back to showing you some strategies while we're waiting for our callers to call in with their math homework. They must have some tough problems. They are persevering on their own.
Is that what it is?
That's what it is. They're persevering.
Perseverance is good. That's a good thing.
That's right. Also, another good thing is solving problems different ways.
Okay.
Can I show you some different ways today?
Please.
Okay.
I'm always willing to learn.
Okay. So I think the last time, I can't even remember what I showed you, 54 minus something, I think 28.
Right.
I think that's what I did last time.
Yes,
I'm going to go back to subtraction again because that's what I did all day long. It seems like that's what my life is about right now.
Subtracting.
Now, I showed you the regular way, and then I used place value blocks, but I also wanted to show you where I split it apart. So 54 is 50 plus 4. And then 28 is 20 plus 8. Okay? And I think when I did it the last time, we got 14 ones and 4 tens. 14 minus 8 was 6, and 4 minus 2 was 2. Now, I told you a cute little rhyme. I said, oh, more on the top. No need to stop. More on the floor. Go next door.
Hey.
But some of my second graders, you will be surprised to know, especially my friend Jason, he really does understand negative numbers. And
Really?
he said, yes, he said, you can do 4 minus 8, and you can do 4 minus 8, and then you get negative 4.
Ooh.
And then you do 50 minus 20, and that is 30. And then if you put that together, 30 minus 4 is also 26.
That's pretty advanced. I like that.
Yeah, and he's really smart. So he
Wow.
really is getting that. So
What
I'm very
grade is
proud.
this?
Second grade. My kids
Second
are smart,
grade?
Mr. G. My kids are the
Second
bomb.
grade?
Oh, yeah.
He
oh, yeah.
knows integers. He knows negative numbers like that.
He just knows that it's
I am
not. He knows you owe 4.
Impressed.
Get 4, owe 4.
Right, but most students wouldn't come up with the negative like that. They would have done, like I said earlier, 8 minus 4.
Yeah, he came up with the negative. Now, he didn't quite know what to do, how to finish off the problem, but we worked through that together. And so now he knows that that's another way that you can solve it. This way, actually, I think works better for older students, when like 4th, 5th graders. Once you do know about negative numbers, then it's actually very easy to put this into practice. But, of course, this is our good old regular way. Just something different.
That was really cool. I like that.
Thanks.
Let me try a couple of those at home.
Okay. But you said you were working on fractions. I like fractions too.
Fractions, yeah.
Fractions.
That problem we just solved was a meaty one. I could do another one now.
That was a meaty one. Did you want to talk first about 1/10 and what was it? 1/10 and 2/5?
There were 2/5, right.
Yeah, and I tell kids it's like apples and oranges. You can't add these or subtract these because it means like 1 of the tenths and 2 of the fifths. It's like having 1 apple and 2 oranges.
Absolutely.
You can't do that.
What we always have to consider is where that bottom number, that denominator, comes from. And it comes from the relationship to the whole. So we have 1/10, but that 1/10 is because 1 whole got broken up into 10 equal pieces.
Oh, so that's 1 of the 10.
Of the 10. And the fifths, for some reason I don't have fifths today. They're home.
I guess you took them
dinner.
home. I know.
But this whole got broken up into 5 equal pieces.
Oh, and you have 2 of the 5 pieces.
And I have 2 of the 5 pieces.
Oh, so another name for 1 whole would be 10 tenths. If I have all the tenths, I'd have 10 tenths.
Absolutely.
And if I had all the fifths, I would have 5 fifths.
fifths.
Oh, so this is just another name for the number 1.
For 1 whole.
1 whole. 1 whole. Hey, I got it.
Right.
So anytime the numerator and denominator are the same, I'm noticing it's 1 whole.
That's right, because that means you have all the pieces that it's broken up into.
Oh, okay.
So if it's 1,000,000 pieces and you have all 1,000,000 of them, let's say they're dollars,
Ooh, that would be great.
you have the whole 1,000,000 there.
Awesome. Well, maybe we can do another one of those examples. Hopefully Felicia's still watching. And
oh, you know what? Oh, no, that's my 4th.
How about we do this one? How about 5 1/2?
5 1/2.
Plus 1 and, ooh, that would be kind of hard. But we can try it. 3/4. Let's do that.
Oh, see, you loaded the dice. Oh, my goodness.
Yep.
Oh, my goodness.
Well, we can do 2/4
Let's see if
today.
I have 3/4.
If you don't have 3/4, then I
think
can
I have
totally figure it out.
3/4.
I'm trying to make it more challenging for you.
I like challenges.
Here's 4ths.
So I have my
more 4ths.
4ths.
I have lots of 4ths.
So I have 1/2 and I have 3/4.
Right.
So again, they're not the same.
No, they're not the same. You can't
They're
add them.
not
It's like
the
apples and
same.
oranges.
They're not the same. So we have to turn them into the same.
The same. What?
So, but watch this. This is really cool. So we talked before about how do you turn one to the other.
Yeah.
So it's can you turn them one into the other? So
Of course you can.
if we use the idea of a least common multiple, which means if I write out the 2 times tables, I have 2, 4, 6, 8. In other words, 2 times 1, 2 times 2, 2 times 3, 2 times 4.
Right. Okay, I got that part.
And I did the same thing for the 4 times tables. 4
Okay.
times 1, 4 times 2, 4 times 3.
Okay. Oh, I see. I see. It's the same, 4 and 4.
Right. The least, or the first number that you get to that's the same, is 4. So that means I can turn these halves into fourths.
Oh, you can. Look.
So it just so happens that exactly 2 fourths are the same as 1/2. So I can change them. It's kind of like that whole regrouping idea.
It is.
So
because you're just it's the same amount. You're just making it look different.
Right. So now I have the 2 fourths, and I already had 3 fourths before, so I'm adding all of those fourths together. But here's what happens now. Once I take those 2 fourths and I'm add them to 3 fourths, I have 5 fourths.
Oh, 5 fourths. That's kind of tricky.
5 fourths. Now we have an issue where the top number is bigger than the bottom number. Do you have a song for that?
No, I have no song for
You
that.
have no song for that. Okay, so what happens now is, can I take a whole fraction or 1 whole away from this 5 fourths?
Sure you can. Let me have the blue.
So here's my whole.
Okay, so here, look, here's 4 of them right here.
4 of them, look at that, works
4 of them makes a whole.
perfectly.
So if you take 4 fourths out.
So if I take 4 fourths out, if I take that 4 fourths, which is equal to 1 whole, I can put that whole now
in
with
the
my
whole pile. And you still.
And I still have 1 fourth left over.
Okay.
So 5 whole plus 1 whole is 6 whole, plus the 1 whole that we took out of the 5 fourths is going to give me 7 whole. And that 5 fourths now, minus the 4 fourths, leaves me with 1 fourth.
Oh, so now it's a
So
whole
now
7.
my answer is 7 whole and 1 fourth left over.
Oh, okay.
So my answer now is 7 and 1 fourth.
Wow, that is kind of tricky. Well, we made it through that one. We can try another one. I won't give you such a tricky one this time.
You can give me a tricky one. I like challenges.
You like challenges?
I don't run away from challenges. I always persevere.
How about 2 and 2/6 plus 3 and 1/3?
Okay. Let's see if I have some thirds here.
I think we have thirds and 6.
I have a third. Do I have 2/6 here? I have 2/6. Woohoo! Yeah. Yeah. Ooh-wee.
Nice. Okay.
So,
two
and we're
six.
adding them, right?
Right, we're adding.
Okay.
So that's not so hard.
Again, I don't have common denominator.
No, you don't.
So I have to make them into common denominators.
It's like oranges and broccoli.
Oranges and broccoli. That's an interesting combination.
Because it's orange and it's green for broccoli.
I got you, but I don't think I would eat that combination.
No, I don't think I would.
Something very special.
No, I still. Ugh.
I don't know any recipes other than salad.
I don't like with those mandarin orange
you
things.
Like
no.
oranges with your vegetables.
No, I
Okay.
don't. No.
Okay.
I'm a salad snob.
Okay. So we have our 3 times tables. 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. On and on and on. 6 times tables. 6 times 1 is 6. 6 times 2 is 12. 6 times 3 is 18.
Wait,
on
stop.
And on and on.
I see it. I see it.
So now that means that I can make everything sixth.
Okay.
So my 1/3 now, if I turn these to sixth.
I see.
My 1/3 works out perfectly into 2/6.
2 of the 6.
2 of those 6
Oh,
is equal
it
to
fits.
1/3.
Okay, so now this is what I have.
Which means I took that 1/3 and I broke it up into 2 equal pieces.
Okay.
And once I do that, they become 6 because now I'm going to have 6 pieces in relationship to the whole.
Right. So now you need 2 of them.
So if I had 1/3 and I broke it up into 2 equal pieces, now I have 2/6.
So now this is what the fraction is that you have.
There you go. So now I have 2/6 plus 2/6, and I have 4/6, and 2 plus 3 equals 5. But guess
those
what?
look a lot of small pieces. Can we?
I'm not done.
Can we simplify
right.
it?
So my question I always ask is, if these were pennies, or if it were money, would you rather have a bunch of pennies or dimes? or quarters?
Yeah, I don't want a whole bunch of pennies.
I want
It's
a
too
whole
heavy.
bunch of pennies. So
I might
always
lose them, too.
ask, what's the least amount of pieces that you can make this into that's equivalent? So I could, and that's what simplifying is, making it into the least amount of pieces. So it just so happens now the question I'm asking is, what factor do 4 and 6 have in common? So 4
Well, they're even.
and 6 are both even, so I know they both have 2. So 1 times 4 and 2 times 2, 1 times 6 and 2 times 3. So these numbers are very close together. You said, hey, they're both even.
They're both even.
So they both have 1, they both have 2, and that's it. So the greatest common factor that they have is 2, which means that I can divide each of these by 2. 4 divided by 2 is 2. 6 divided by 2 is 3. So that means the least, if I put 2 of those together and 2 of the other ones together, they will wind up with the least amount of pieces I will have are 2. And 2 of what? 2/3.
2 of the thirds. So now, bam, here we go.
Right.
So it's 5 and the 2/3.
5 and 2/3.
Wow. Yeah.
And you always simplify. I have to stress that. Always simplify.
That's right.
That's what happens when you go to the grocery store and you get change back.
Oh, nobody wants
They
$7
don't give
in
you
pennies.
right.
No.
Nobody's going to give you $5 in quarters.
No, that's not
do it.
efficient.
So
See, in
simplifying
second
is
grade,
giving
we
you the
don't
least-
we don't do a whole lot of fractions yet.
Right,
But we do talk about efficiency as
There you
opposed
go.
to simplifying it, because it doesn't matter what kind of math you do. I mean, there's lots of different ways, but there's always usually an efficient way, the most efficient, the
Exactly.
fastest, the easiest way. You determine how you define efficient.
Right.
But
Now
yeah.
you can use your own way, but that's always the question. Is it the most efficient way?
That's
so
right.
again, if that were money, you wouldn't want a whole bunch of quarters back for your change. You want
it's too heavy, and no
quarters.
way.
You want dollars.
Absolutely.
When you can make dollars, that's the least amount of pieces, also the lightest amount.
That's right.
So that works out better.
Wow, fractions, and woo, it makes my brain hurt.
Why? It's just sharing. It's taking a piece of a whole and making it even portions.
Okay, if you say so, Mr. G.
It's always about fairness in math.
Fairness.
Yes.
And it just seems to me to be about switching. It's about the same number, just a different form. It just looks different.
But it has to be equal.
Oh, equal form.
It can't just be any number. It has to be equal portions.
Equal. Okay, I get you. All right, so what else do you want to talk about? More fractions or something else?
You seem to like fractions, even though you're
like
having some
fractions.
challenges with it.
I have some challenges with this one, though.
What?
How about if I had 5 and 1/4, and I wanted to take away 3/4? See, I don't understand when you do that, Mr. G.
That's just like if I have $5.25 and I'm going to pay for something that costs 75 cents.
Oh, so you're saying even though the denominators match, I don't have enough? Oh, this is like my rule. This is like my my song.
What's your song?
More on the top, no need to stop. More on the floor, go next door.
Oh, look at that. It works. So it works in more than one concept,
It
huh?
does.
Okay, so I like that. So now we have 1/4 here. This is my fourths.
Oh,
You have my
I stole
fourths
them.
over there?
I stole them.
I have 1/4 here, and I don't have enough fourths to take 3/4 away. So now I have to take one of the whole
Yeah.
and turn it into fourths.
Oh.
And when I do that, it's going to give me 4/4. So what happens is I take one whole, borrow it, that becomes 4, and that one that I borrow becomes 4/4. And I add them all together. So I have my 4/4 and my 1/4, and that would give me
5/4.
5/4.
Oh, I get it. It's just like subtraction.
It's the same
Except I'm not cutting it up into 10 pieces.
You're
Now.
cutting up. That is telling you that you need fourths.
Oh, I need
so
4
that
pieces.
one whole that you are changing, is going to become fourths. So if that were 6, that one whole would become 6. If it were tenths, that one whole would become tenths.
Oh, that's really not that hard because it tells you right there.
Tells you right there.
Okay, so now you have 5/4, which we don't have because we don't have another set, minus 3/4, but the denominators are the same, so it shouldn't be hard. I just subtract the
I just have to take 3/4 away, and that's going to leave me with boop, boop, 2/4.
2/4.
So 5/4 minus 3/4 is
2/4.
2/4.
Uh-oh, but that doesn't look pretty.
I have 4 whole left over. Now, here's the indication that you can simplify, make this less pieces. Again is, well, 2 and 4 are both even numbers, so that means I can divide by 2.
Absolutely.
So that 2/4, the least amount of pieces that I can make that 2/4 into is 1/2.
They're equivalent. It's the same, but you only get to carry around one piece. It's more efficient.
There you go.
I like that word. It's my word of the year, efficient.
Efficient.
Yep.
That's a big word for second graders.
Oh, no, we have a big word wall. We call it the big kid word wall, and we write all of our...
Big kid word wall.
Because we're big kids. We're so
I'm
awesome.
a big kid now.
That's right. So we put efficient on our word wall because it's more efficient to carry on 1/2 than 2/4.
Exactly.
It's just easier. And I like your quarter correlation there.
Sure. If it were money, if I had $5 and 25 cents and I wanted to subtract 75 cents, works a little bit differently.
It's a little easier.
But it's the same idea.
Yeah, it
So I can take, I have 500s minus 500s. That's going to leave me with 0 So now we have a little problem here.
Oh, yeah, we do.
Because I have 2 tenths and I need to take away 7 tenths.
Not enough.
But I don't have enough tenths.
No.
So I'm going to take $1 and turn it into $4.
Okay.
And then I'm going to take those tenths.
Okay.
That dollar is going to turn into 10 tenths.
Oh, yeah, because we're
10
talking about
tenths,
money.
Right.
Okay.
So now that 10 tenths with the 2 tenths is going to give me 12 tenths.
Oh, then I can subtract.
So 12 tenths, and I can take away 7 tenths. I'll be left with 5 tenths. And $4.
Minus
Not
no
going to take any
dollars.
dollars away. So $4.50, which is also 4.5.
Oh, they just look different. Numbers are the same. They just look different. Oh, excellent. I like that. I'm going to give you a little star.
Hey,
I love it.
I like stars.
So what else can we do? What other kind of fraction stuff? Now I like fractions. Now fractions
Well,
are
I'm glad I made that
cool.
fun for you.
Fractions are cool now.
Yay! I think I get a star for helping you learn fractions today.
Okay, but what other kind of fractions? I don't understand this kind of fraction again.
You have a lot
5
of fractions that you don't
fourths.
understand.
I don't like that one.
Oh,
I don't like that. What about that?
That's called, I don't like the name that this has. It's called an improper fraction.
Improper.
It's an improper fraction because usually a fraction is what? A part of a whole, right?
Right, right.
So part of a whole means you usually have the top number is smaller than the bottom number because it's part of a whole. Well, this is improper because you have more than one whole here.
It's still part of a whole. You
It's
just
still
have
part of
more,
a
a
whole.
lot of them.
You have a whole and a part.
Oh, okay.
So this number tells us the whole is broken up into how many equal parts?
4.
4. So this one whole is broken up into 4 equal parts. That means it only needs 4 to equal one whole.
Oh, okay.
So it's just like as if I said that I had 4/4 and 1/4 more.
Oh.
So that 4/4 is equal to 1 whole.
Oh, I see.
And 1/4 more.
Okay, I get it. So it's 1 and 1/4.
1 whole and 1/4.
Now I get it.
So you're always, whenever you can make 1 whole, you're going to make 1 whole.
Wow, okay.
Or as many whole amounts that you can possibly make.
I get it. See, fractions they're not that much different than regular
They're
regrouping.
really kind of friendly.
We have a call. We have a call, Mr. G.
Ooh, we have a call.
Hello, welcome to Count on Us. Who is this?
Fatima Bundu.
Fatima.
Hi, Fatima.
Fatima, are you calling from Perrywood?
Yeah.
Excellent. I know Fatima from Perrywood. Yay! It's one of my favorite students. Fatima, what are you working on today?
2/3 minus 1/4.
Ooh, just what we were doing
just
today.
what we're talking about, huh? 2/3 subtracting 1/4. Ooh, that's a little meaty.
It's not hard. It's just apples and oranges. We have to change them, Mr. G.
We sure do.
Okay, Fatima, where do you think we should start? What have you learned so far?
You have to do 2/3 minus 1/4 with starting with the numerator first.
We do, but look at the denominators, Fatima. Are they the same?
No.
No. So we have to make them the same first, right?
Yeah.
So if I have 2/3, Mr. G is going to show you, 2/3, and I want to take away 1/4. Do you see any 1/4 pieces up here?
No.
No, there's no 1/4 up here. So we have to change this into something that we can use. We have to change it. We actually have to change both.
Yeah. Sure do.
Now, do you know the least common multiple for 3 and 4? When you count by 3s and when you count by 4s, do you know the first number that you say on both lists? If you don't, we can help you figure it out.
Okay.
Okay, so let's count by 3s. You know how to count by 3s?
Yeah.
Okay, say them for me. 3. What comes next?
6.
Yep, then what's next?
9.
Uh-huh.
12.
Good. One more.
15.
Great. Okay, now let's go to the 4s. 4.
8.
Great. What comes next?
12.
Uh-oh, we can stop there. You know why? We found one on both lists, Fatima. Okay, you see how they're on both lists?
Yeah.
Okay, now we can take the 1/4 and change it into something that's broken up into 12ths. Mr. G is going to show you here. If you take a couple pieces and put them underneath the 1/4, you'll notice that 1/4 is the same as how many of those pieces? Can you see?
3.
Right, 3/4, okay? 3/12, and if you multiply the numerator and denominator by 3, you'll get 3/12. All right, now what about this one up here? I want 2/3 is the same as, we need a lot of 12ths for this one.
1/4.
Ooh, we're going to break them into 12ths. Let's see how many 12ths we need. Okay, so let's count them. 1, 2, 3, 4, 5, 6, 7, 8 12ths. Oh my goodness, that's a lot of 12ths. Okay? Now we can subtract.
We turn them into the same kind. You understand that, Fatima?
Yes.
Okay, so this one needed 3 of them, and the 2/3 needed 8 of them. So let's subtract. Now we have the same denominators. So let's subtract 8 minus 3.
So I have 8 of them now. Can I take 3 away?
5.
Very
1, 2,
good.
3. Oh, wait, at least 1, 2, 3, 4, 5.
Excellent.
5.
5 of the 12. Excellent.
Can we simplify it?
Yeah.
You can? Well, if you could simplify, that means 5 and 12 have to have a same factor. So 5 has 1 times 5. 12 has 1 times 12, 2 times 6, 3 times 4. So they don't have anything in common but 1.
Nope. So we
so
can't
you cannot
simplify
it. 5/12 is the best we can do. That's our answer.
All right, Fatima, I hope that helped. 5/12 is your answer, okay?
Okay.
All right, have a great day. We put your name in the treasure chest, Mr. G. Would you like to take?
And today's
winner
is Felicia from Cherokee Lake.
Very good, very good. Thank you to our callers again. Please stay tuned for the intermediate edition to follow right after our show. Remember, the number is 301-772-0080. Thanks for calling. And remember, you can always count on us.
Welcome to your mini lesson today. My name is Mrs. Jacks, and today we will discuss how to change mixed numbers into improper fractions, and the reverse of that, how to change improper fractions into mixed numbers or whole numbers. Let's go ahead and look at an example. In this example here, once again, it says changing mixed numbers to improper fractions. We have a mixed number here. A mixed number is when you have a whole number paired with a fraction. This one happens to be 3 1/8. We're going to go ahead and change that into an improper fraction. The first step is to multiply the whole number by the denominator. So 3 times 8 is 24. After you do that, well, let me go ahead and show you. 3 times 8 equals 24. You have the numerator here. We're going to go ahead and now add the numerator to our product. 24 plus 1 equals 25. This final answer becomes your new numerator, and the denominator stays the same. So 3 1/8 changed to an improper fraction happens to be 25 over 8. An improper fraction means that the number on top, which is the numerator, is greater than or larger than the number on the bottom, which is the denominator. We can also reverse this. We can change improper fractions back to mixed numbers, and I'm going to show you how to do that now with this second example. Changing improper fractions to mixed numbers or whole numbers. This first one here is an improper fraction. Once again, that means that the numerator is larger than the denominator. The first step is to divide the numerator by the denominator. Okay, so I'm going to set this up as 56 divided by 7. If you already know the answer, you can of course put the answer here, or you can set it up the long way using an algorithm. 7 goes into 56 8 whole times. 8 times 7 is 56. And then with the algorithm, you will go ahead and subtract, and your answer is 0 here, so you don't have anything left over. There's nothing else to continue dividing by. So your answer happens to be 8. So in this case, you can change an improper fraction to a whole number. Let's look over here. This one is a little different. This is 55 divided by 7. So it's one number less than 56. Let's see what happens when we do that. 55 divided by 7, we will do it the same way. 7 goes into 55. It doesn't go exactly 8 whole times. It's going to go in 6 times, and then we're going to have something left over. So let's go ahead and set up the algorithm. 55 divided by 7. Well, I'm sorry, I said 6 times. Excuse me. It goes in 7 whole times. So 7 into 55 is 7. 7 times 7 is 49. To complete the algorithm, you need to go ahead and subtract. 55 minus 49 gives you 6. So 6 is your remainder. Now, to set up our answer, the whole number here becomes our whole number for the mixed number, and then the remainder becomes the new numerator, and guess what? The denominator stays the same. So 55 sevenths, which is an improper fraction, now becomes 7 6/7 as a mixed number. Once again, this was a short mini lesson on changing improper fractions to mixed numbers and changing mixed numbers to improper fractions. Thank you for your time.
Minds can achieve anything. make sure they get to college. Federal student aid provides more than $150 billion in grants, loans, and work-study funds to make college possible for anyone with the mind to get there. Because if given the chance, minds will do great things. Federal Student Aid, proud sponsor of the American Mind. Learn more about money for college at studentaid.gov.
Because how many ways are there to solve math? Many!
Your live homework help starts now. Welcome to Count on Us.
What is the length from the entrance to the giant wheel?
All right, so let's add 3 here and see what happens.
First, I need you to double check yourself. So the second equation for solving perimeter is?
2 times length plus 2 times width.
Hello out there in TV land, and welcome back to Count on Us, your favorite math call-in TV show to answer all the questions you might have. I'm Ted Herman.
And I'm Miss McCants.
My lovely partner over here who knows everything about middle school math. So if you came in today on the middle school math end or high school questions, we will take anything you have. Just call us here at 301...
772-0080.
Oh, she's like pure snow coming through on a winter's night. She's so smooth. And you also reach on the World Wide Web at www something, I forgot what it was.
PGCPS.
PGCPS.org. And go right down to podcasts. You can catch on the computer. But whatever you do, whichever way you contact us, by phone or by pigeon or by plane, just turn those TVs down so we can hear your lovely voices and your questions. Do we have any challenge today, Ms. McCants?
We do have the 24 challenge. And card A, is a 9 or a 6?
I think it's a 9 because it's colored in.
A 9, it will be colored in. 4, 8, 5.
And before you go on and I read these numbers out loud, what's the goal of the 24 challenge?
The goal of the 24 challenge is to make 24 using any operation, addition, subtraction, multiplication, or division.
That's how you do it.
So we have to use a combination of the 4 numbers with any of those operations.
And you must use all 4 numbers.
And you have to use all 4 numbers.
Fantastic. Well, the next one, which is letter B, is 3873.
And card C is 7, 8, 2, and 4.
And card D is 3477. And the reason why we're asking you to look at those numbers closely, can't they solve it at home and call back or whatever?
They can call at home and give us a call back.
We have another challenge for them today, and I think it's this special challenge right here. Do you want to go over that, Ms. McCants?
So it says the number you are looking for contains 3 digits. The first and second digits equal the third digit. The first, second, and third digits equal 12. The 3-digit number is?
Greater than 200.
Is the number 624, 347, 156, or 246?
Well read. So this is actually basically a multiple choice type question. They have the answers right there, and they got to make some sense out of the numbers. Well, I think we're about ready to start the show, Miss McCants, and we're ready for our first caller.
Yes, we
and
are.
I believe you're going to get, I got to start out before I say the first caller, but I think a lot of people from Gwynn Park Middle School
That's
are
right.
calling in, and I'm very upset because I didn't get a chance to get makeup on before the show.
What? You look great.
Well, I was hoping you'd say that, but
Yes.
I feel a little deficient today.
No,
So
you look wonderful.
well, you look better than I do, so take the first caller, Miss
Okay.
McCants, you're
Just
great.
because I look better than you, you're going to let me take the first call?
Absolutely,
Okay.
every day.
So right now, I think we have Arjane on the line. Arjane, are you there?
Yes.
Hi, how are you?
Good.
Who's your math teacher, Arjane?
Miss T. McCant.
That's right.
That'd be you.
Yes, that's me. And what school are you calling from?
Gwynn Park.
Gwynn Park. Can I ring the bell?
Ring it all you want.
That's for you, Arjane.
Arjane.
Arjane, what's your question?
What a cool name.
44 over 8.
44 over 8. What are you supposed to do with this 44 over 8, Arjane?
Divide.
Divide, okay. So now you're going to divide it. Can I set it up like this?
Yes.
Because it's technically saying 44 divided by 8. Okay, and so I set it up this way. 8 goes into 44.
5.
5 times. Okay, Mr. Herman, is there a special way that you show your children how to divide?
You're doing great. The only thing I would emphasize is that, Arjane, what kind of fraction do we call this? 44.
Improper fraction.
Improper.
Fraction.
And I think we're going to change it over to a what kind of fraction, do you know?
A whole.
A whole number and a fraction, which is called a M word. M is in Mickey. What kind of fraction would that be if you changed it to a whole number and a fraction put together?
Mixed number.
Oh my goodness! You must have a great middle school teacher over there teaching you the math, because you know all the vocabulary.
Mm-hmm. So you're going to have a mixed number. So let's finish working this out.
Absolutely.
So we have 8 times 5, which gave us the 40.
Mm-hmm.
So now what do we do? 44 minus 40 is how much?
4.
4. So are we going to use this as our new numerator?
Yeah.
Yes. 4 over 8. So we have 5 and 4 eighths. Is this in lowest terms?
No.
So what do we need to do to 5 and 4 eighths?
You can divide 4 and 8 and get 2 over 4.
So you're going to divide by what to get 2 over 4?
2.
You're going to divide by 2. Is there something else I can divide by that's bigger?
4.
4. I can divide by 4 with a numerator and denominator. And get 5 and what?
5 and 1/4.
5 and 1/4 or 1/2. 8 divided by 4 goes in how many times?
2.
2 times. Okay, so your answer is going to be 5 and
1/2.
1/2. Thank you for
Excellent.
calling, Arjane. That was a
Excellent.
great start to the show.
Huh.
So I'm going to see you tomorrow, okay?
Okay.
And
Thank
your
you.
name goes in. Does Arjane want to try a challenge
Arjane,
today?
did you want to try a challenge? Do you need me to put the numbers back up for you?
No.
You sure?
Yes.
Okay. So you give us a call back later if you change your mind.
Okay.
Okay?
Bye.
Bye.
Nice job, Arjane. Very nice.
Yeah, she's a great girl. She's a wonderful student.
And you're getting the most out of her by teaching her great stuff.
Thank you.
If you don't mind, we have another Gwynn Park student calling in for you, because my
Yes.
student from Mount Ranger's coming
Okay,
after.
so fine. I'll take this next student. I'll take this next call.
This is totally unrehearsed, people,
Yes,
but we worked it out
we
beautifully.
have a
we
team.
cooperate.
It's a system going on here.
Teamwork.
Isaiah, are you there?
Yes.
Hi, how are you?
Good.
I see that you're calling from Gwynn Park. Let me ring that bell for you. And yes, you are in my class, correct?
Yes.
And I see that you're calling with the integers question.
Yes.
What's your question, Isaiah?
-6 minus -5.
-6 minus a -5. Okay, so what do you notice about this?
The two numbers are negative.
The two numbers are negative, and what's going on here with this subtraction? Okay, if we had a number line.
Okay.
If we had a number line, let's say our 0 is here. From 0, where would we go?
Backwards.
To the left, right?
Left, yes.
By how many?
6.
Okay, we would go to the left. 6. And now what?
Do you go to the left 5 times?
Okay, we would technically go to the right, and then we would see that it was negative, and then go back to the left.
Oh, right.
Does that make sense?
Yes.
So if I was facing this way, I would start going back in the opposite direction, but the negative is telling me to go back this way. So I would go back. How many more spaces?
5.
5 more spaces.
1 second, Miss McCann. I don't mind. Hope you don't mind me interjecting.
Sure, no.
I would definitely go with that first move. So you're already at -6, and you're going to go further back to the left by negative. But then this tells you to go which way, Isaiah?
To the right. You're right.
To the right.
I'm glad you're here.
Well, I just like to fill in whatever knowledge I might
Mr. Herman, you are absolutely right. So Mr. Herman is saying that we should go back to the right 5 spaces, and where will we land?
-1.
And we will land at -1. So our answer is -1. And there's another way we can do this. Can I show them quickly?
Absolutely.
So we would have -6 minus a -5. We could also say that we're going to add the opposite.
There you go.
Okay, we could add the opposite. So I have -6, add, what's the opposite of -5, Isaiah?
+5.
A +5. And the rule for adding integers is to subtract when we're adding. We're going to subtract because our signs are different.
Okay.
Okay, so what's 6 minus 5?
6 minus 5 is 1.
Is 1. And we're going to take the sign of the greater absolute value. Which one of these are furthest away from 0?
6.
-6. A -6. So our answer is going to be a -1. So that's just another way. We could add the opposite.
Okay.
Or keep, change.
Okay.
Okay?
Yes.
All right, Isaiah. Mr. Herman is putting your name into the treasure chest as we speak. Did you want to try a challenge? Isaiah? Okay. All right, so we'll catch Isaiah next time. Who do we have next, Mr. Herman?
Now it's my turn to show off
he
my
want to show
Mount
off.
Rainier people.
Let me give the bell.
See that?
I see it.
I'm ringing the bell.
He's
and
ringing
watch
that
for me
bell.
the next few weeks on the holidays coming. I'll be out in the sidewalk with that bell ringing. They used to call me Quasimodo, the bell ringer.
Oh,
from Notre
Quasimodo.
Dame. Yes, I'm so proud of that. Is that Zoe? Hello? Hello-y? Is that Zoe? Hello? Zoe? Anybody there?
Zoe, are you there? Uh-oh, I
waited
don't
all
hear.
night for
Yeah,
Zoe,
I know,
and now I don't hear anything.
I don't hear you.
Zoe, you're not there anymore?
Okay, well, she can call us back.
She can call us back. Can we go to our next caller? Khadijah.
Is this someone that you know?
I've had Khadijah call in here a lot.
I know.
Khadijah's a regular caller.
You guys are friends.
We're friends.
I think you're friends.
We're regulars. All right. Khadijah, you're on the air. How are you doing today?
Hey, Khadijah, how are you?
Fine.
Aren't we tight? As you know, we've been working together so much. You're a Kettering Middle, aren't you?
Yes.
And Khadijah, who's your teacher at Kettering?
Miss Brady.
Miss Brady?
Yes.
Tell her we said hello from Count on Us.
Okay.
So what's your question
Miss
today?
Brady's part of the bunch.
I have adding and subtracting integers.
What?
I have adding and subtracting integers.
Okay, so what is your question?
Oh, that's a good idea. Good way to go. That's how the show works.
Say it one more time.
51.
51.
Minus -2.
Minus a -2. That's something similar to what we just did with Isaiah.
And if you don't mind there, Khadijah, I might try to show you a little touch different than what lovely Miss McCants just did. I'd like to say it a little bit different. This is a subtraction sign. That's a negative sign. So what's the opposite of a negative?
A positive.
I love it. Khadijah is so always on the ball. But I'm going to try something a little special here for Khadijah, if you don't mind.
Sure.
Oh, you're great. You're great. Watch this.
I'm just trying to assist.
You're more than an assist. You're like dynamically in charge.
You know what? I think you did this before, Mr. Herman.
I hope it works out better than the last time, because that was a disaster. You know what I'm saying?
I know what you're saying.
You saw it then.
I did.
Okay. Khadijah, you just said actually, the opposite of a negative is a positive. Watch how this works. No hands. This is beautiful. I always want to be a magician. Now I take the subtraction sign, and I take the negative sign, and watch.
Uh-oh.
It didn't work so
It's
great.
a little short.
A little short. Okay, let's try this again.
Try that
Oh my goodness. Is she a
Teamwork.
great, that's called teamwork,
Teamwork.
folks. That's how it works in this county. You work together and you have teamwork.
Pow.
Now, pow.
There
Bam! What does
There
that
it
mean?
is.
How do you say that now, right? Come on, Khadijah. Bring it on, babe.
Positive.
Oh, what'd she say?
She said a
plus.
positive.
Oh, yeah. So basically what I'm saying here is I'm so excited. I'm joyous. This has become positive. So what's 51 plus 2 more?
53.
Oh, Khadijah, you make my heart sing with joy. She gets her name in one time.
does.
And if you want to try a challenge, Khadijah, you're the star. You want to try a challenge today?
Yes.
Which kind? The 24 challenge or the mystery numbers?
The mystery numbers.
Oh, I think she's on to us. I think
Okay.
she's got it. And so I'll put her name in there with you, and we're going to put her in the box, right in the treasure chest, to be
There
pulled
it
out later.
is.
And let's go over this again. The number you're looking for contains 3. I say 3 digits. The first and second digits equal the third. Oh, I guess that means when you add them together, you get the third digit. Is that what it says to you?
Stop giving them hints. They have to know what you...
The first, second, and third digits equals 12. I'm not going to tell you anything else besides what I just read. The 3-digit number is greater than 200. Is a number, that number, that number, that number, or that number? Huh. Okay, Khadijah, I hope you know more than I do. I'm really confused on this one. This is pretty tough. Boom, 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 boom.
Is it, 246?
Well, let's just double check. The first and second digits equal the third digit. 2 and 4 make 6. So far you got that right. The first, second, and third digits have to equal 12. 2 and 4 make 6. What's 6 more, Khadijah?
12.
Uh-huh. Is this 3-digit number greater than 200?
Yes.
Yes, it is. You know what? It's time for the bell! Because she got it! She got it, Khadijah!
Name goes in the treasure chest again.
You just doubled your chances of winning the big prize. I think I hurt my shoulder. I'm not sure. Okay. We're going back. And Khadijah got her name in twice. That's how you do it, callers. You got to get a great question answered and solve the challenge. Let's go to our next caller out there. Is that Zoe?
I think Zoe's back.
Yes.
Hey, Zoe.
She's back.
Mr. Herman was so sad that you weren't here.
Hey, Zoe, one of my favorite students in the 4th grade class this year. You better believe it. And what grade? What? What'd she say?
I don't know. Say it again, Zoe.
I said I am your favorite student.
Oh, okay.
Well, I didn't say the favorite, but you're one of my favorites. You're in my heart. I got you right here, Zoe. I love you to death. What is your 4th grade problem today, Zoe?
4/8 minus 6/3.
4/8 minus 6/3. Did I write that down, Zoe? Right, Zoe?
Yes.
Hey, Zoe, can I ask you a quick question? Where did this problem come from?
What did you say?
Did this come from a book, your imagination, or La La Land? The only reason I'm asking that, Zoe, is because I've never seen a problem like this. And unless we're going to work with negative fraction, it's going to be very tough to solve.
Okay.
So, is there a problem in your book we can do together?
20 times 30.
Oh, I'm sorry. Say that one more time.
Way to change
20
the
times
problem.
30.
Okay.
She said something.
20 times 30.
Oh, I like that one. 20
Which has nothing to do with fractions, but
30.
she's quick.
She
Zoe is very quick
on her feet.
Quick on her feet. And,
That's why she's one of your favorites.
she can change like that
Mm-hmm.
from a fraction to a multiplication. Do you mind doing the multiplication while I go over? I can't reach that way, but can we do?
Sure.
Zoe, can you give me 0 times 0?
0 times 0. Zoe? Okay, well, we can work this out.
Let's work it ourselves because we can. Zoe got interrupted by somebody came to the door or something.
Maybe somebody rang the doorbell.
Rang the doorbell or rang the bell.
Rang the bell.
Rang the bell.
So
that
what's
rings
0
a bell.
times 0?
0 times 0 is 0.
0.
And then we go this way and go diagonal. 0 times 2.
And then we're going to go over here.
Uh-huh.
And that's
0 again.
0 again.
And we're going to put a 0 right down there because we're not really multiplying by 3. We're multiplying by 3 in the tens
You're
column.
right. So it's a 0 here.
Uh-huh.
Mm-hmm.
So anyway, 3 times 0 is what?
0.
And then 3 times 2 is?
6.
Oh my gosh, you're great. Zoe, can you finish the problem for us? 0 plus 0 is what?
0.
And turn
Great
down
job.
your TV.
Right.
Talk directly into the phone, okay?
And 0 plus that 0 is what?
0 plus 0 is how much?
0.
Excellent job.
And then there's, go ahead, Ms. McKee, I'm sorry.
I'm
No, well,
sorry.
6 plus nothing above it. There's 6 plus nothing above it.
Is how much?
Mm-hmm.
6.
And what's your final answer, Zoe?
What's the final answer, babe?
600.
I love Zoe.
Yes.
Nice job.
Excellent job. Thank you for calling us back, Zoe.
Yeah, we got worried about you there. Can I put Zoe's name in myself?
Sure.
You want to try a challenge real fast, Zoe? You got the challenge
Did you
figured
want one
out?
of the challenges?
No.
No? All right. Well, call us back when you have it solved. Or call us back another problem.
Yeah.
Maybe you'll change from fractions to multiplication.
Again.
Just like that.
Again.
It's all yours. Nice job, Zoe.
All right, I see Shay. Shay, are you there?
You don't say.
Hi, Shay. How are you?
Good.
And you're calling from?
Glen Park Middle.
Yay! Glen Park Middle School. I'm not going to worry about ringing that bell because Mr. Herman knows what the show is all about.
I'm telling you, that's the most popular call-in show I've ever seen in my life.
Shay, I see that you're calling about integers. What's your problem?
Positive 20 minus
A positive
negative 8.
20 minus a
Negative 8.
negative 8. Did I write that correctly?
Yes.
Okay. So we know that we have a positive and a negative. Mr. Herman just showed us his special trick about having a subtraction. And he said that we need to change the subtraction to what? Addition. And not only are we going to change subtraction to addition, but we're going to change our negative integer to the opposite. What's the opposite of a negative integer?
Positive.
A positive. So now I'm going to rewrite this as positive 20 plus a positive 8. Is that correct, Mr. Herman?
That looks great to me. You're stylish.
So if I have 20 plus 8, how much does that equal?
28.
28. Oopsie. Positive. A positive 28 is our final answer. Mr. Herman, did you already write Shay's name down?
Absolutely. S-H-E-A.
And so it's going into the treasure chest.
Is Shay up for doing a challenge, probably?
Shay, do you feel like doing a challenge before we go to break?
No, thank you.
Are you sure?
Yes, I'm sure.
Okay, Shay. Then I'll see you tomorrow, all right?
Yeah.
All right. You have a good night, and thank you for calling.
Do we have time for another caller for the break? I think we might. Who's that?
Looks like Julian.
Julian? Oh, my gosh. I can see Julian right there.
Julian, are you there?
Oh, he's great.
Oh.
Hello, Julian. How are you?
Hi. Good.
Oh, Julian, I know where you sit in class. He's so alert, so bright. And if I ever make mistakes in class, he just sits there in his seat very politely and laughs at me. But other than that, he's also very sharp, too. He knows everything I do. So, Julian, show off some of your knowledge. What's your question today, Julian?
Okay, it says a piece of poster board is a shape of a rectangle.
Okay. You have a poster board in the shape of a rectangle?
Yeah.
Okay.
The length of the poster board is 2 feet and the width is 1 foot. What is the area of a piece of poster board?
Nice writing. So, I'm sorry.
No, I was going to let you do that one.
No, I was just going to say, what is the area formula? What's the formula for area?
Are you a mind reader? I was going to ask you the same thing.
Well, I don't know. I'm working at it.
Huh?
What's the area formula?
Nothing better than a nice close-up.
Okay, so you gave me the length and you gave me length and the width was given?
What?
The length and the width of the rectangle, of the poster board. It was given?
Mm-hmm.
Uh-huh.
So do you think we need both of those things to find the area?
Mm-hmm.
Okay, so I think the area formula that we should use is length times width. And we could also say base times height. Okay?
Cool.
So you said our length was going to be 2 feet and our width was going to be 1 foot, correct?
Mm-hmm.
To find the area. So let's plug in what our length is. What would length be? You said that in the problem. You gave it to me in the problem. You said the poster board was how long on one side?
Yeah.
I think you said 2.
Okay, 2 times, what was the width?
2.
I thought the length was 2.
The length is going to be the longest side, and the width is going to be the shorter side.
Okay.
So you said 2 feet and 1 foot, correct?
Yes.
Okay, so I'm going to plug in 2 for the length, and then I'm going to use the raised dot. I'm going to put 2 times 1.
Oh, uh-huh.
Okay, and so what is 2 times 1?
2.
2, and we're going to say 2 feet squared.
Excellent.
Okay, because we have to use our units.
2 units.
2 feet.
Right. I think Mr. Camp did a great job showing off the area covers everything.
Mm-hmm.
The measurements around and the inside.
That's right.
Square feet. Way to go.
Okay.
He got his name right here.
Julian, your name is going in the treasure chest. Okay, Mr. Herman already wrote it up, and he's put your name in. But if you want to do a challenge, please call us back after the break.
Huh?
We have a short break to listen to.
If you want to do the challenge, call us back after the break. And all other callers, please hold. Do not hang up. We're going to be right back. Don't hold on so hard like Mr. Herman, but come back after the break.
from Samuel Ogle Middle School, and today's email question is from Ted at Rockledge Elementary. Ted wants to know the area and perimeter of a rectangle that measures 3 inches by 6 inches. Well, let's start with the perimeter. The perimeter is around. So we add all the sides. Okay, so we know that if 3 inches is on this side, then 3 inches is on this side. And if 6 inches is on this side, 6 inches is on this side, because the opposite sides are equal. Now we add 6 plus 6. 6 plus 6 equals 12 inches. And 3 plus 3 equals 6 inches. Now 12 plus 6 equals 18 inches, which is the perimeter. Now we do the area. The area is the inside. So we can either count the squares or we can do length times width. And the length would be 6 inches. And the width would be 3 inches. So let's do both. First, we'll count the squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So now we know that we have 18 inches squared since we used the squares. And the same thing goes for length times width. So now we do 6 times 3. 6 times 3 equals 18 inches squared. And this is the area. Well, Ted, I hope that was helpful to you. So that's Cameron, and see you next time.
Wait a minute. That's wrong. All people are people.
Take the time to get to know people, and you'll see that all of these labels are false. Don't let prejudice shape your view. Stereotyping is wrong, and it hurts all of us.
Stop stereotyping.
A message from your American Muslim neighbors.
When I was a kid, I dreamed of being a stuntman.
I went from dream to dream pretty quickly. I wanted to be a cowboy. Tom Cruise in Top Gun.
I dreamt of being a nun.
Actually, before that, it was Popeye.
Malaria kills more than 2,000 children a day.
Text NET, N-E-T, to 85944 to make a $10 donation to Malaria No More.
Oh, messaging and data rates may apply.
Let's make malaria no more.
Well, welcome back to the second half of the intermediate show on Count on Us. I'm Ted Herman.
And I'm Miss McCants.
And we're here to answer all your questions. We've had some great callers so far.
Yes, we have.
And they all have a lot of enthusiasm and a lot of motivation to get their ideas straight.
That's right.
So let's go to our first caller out there who might be Jordan. Is that Jordan? Hello?
Oh, hey, Mr. Bach. Hey.
Uh-oh, he knows you.
Yes, I do.
Oh, my goodness. Is this Jordan Brown from middle 6th grade?
Yes, I do. Yes, it is.
Well, welcome, Jordan. Mr. Herman would love to talk to you today.
Yes, I would. I can't wait to hear from my man Jordan, who's now a 6th grader. He's going to graduate out this year and go to middle school. I had him 2 years ago in 4th grade. And that Jordan, he knows his stuff. He's a very bright kid.
Let's see if he knows his stuff. Jordan, what's your question?
Is 53 divisible by 9?
It's 53.
Oh, divisible by 9? Let's go find out. Now, who's your teacher over there in 6th grade math?
What?
Give your teacher a shout out.
Who's your teacher?
Sponsored to Mr. Bathway. Da, da, da.
Okay.
Say it one more time.
Huh?
Who's your teacher?
Mr. Brathwaite.
Mr. Brathwaite.
Oh, yes. He's next door to me. I can hear him teaching you all day.
Okay.
That's great. Let's find out if 53 has divisibility by 9. Well, there's a nice divisibility trick we know about. Did Mr. Brathwaite ever tell you this one? Can we put a plus sign in between our digits? That's the way we find out if 9 will divide into it or 3 will divide into it. So, Jordan, my man, what's 5 plus 3?
5 plus 3? 8.
Excellent. Will 9 divide into 8 nicely? Look at Miss McCants put that 8 on the screen. Will 8 be divided by 9 real nice? Yes or no?
8 divided by 9? Oh, wait. Oh, that's good.
Will 9 go into 8 evenly?
Oh, no.
She said it right. She said it the right way, so you understand what she's saying now. Now, if that's not going to work, then you can best believe 53 will not be divided by 9 either. That's our tricky test for divisibility rules for 9. If you can add the digits, let's try one more, Jordan. Just give me a bunch of digits. Just yell out a number left and right. Go number, number, number. Okay.
Give Mr. Herman another number so that he can try the divisibility rule for 9 for.
I already put 7 down, so give me some more numbers, Jordan. Give me some more digits.
I can't hear you because those talking.
Okay.
8.
8. Thank you. What else?
9.
9. And one more.
7, 8, 9, 10.
One more digit.
3.
Wait,
Excellent.
10.
3. Okay. Let's add them together, Jordan. I hope you can hear me. What's 7 plus 8? We're going to add the digits together. 7 plus 8.
16.
Excellent. You know your skills in 6th grade. What's 15 plus 9?
15 plus 9. Okay, I might need a second.
You need some help?
One second.
15.
Yeah, we're
Take your time.
We're not
Take your
going
time,
anyplace.
Jordan.
We're still in the chairs.
1 second.
You're fine. Take your time.
Don't hurt
24.
yourself. How much?
24.
Excellent. So we have 24 plus 3 more, Jordan. Just do that 3 more plus 24.
27.
I love my man Jordan. He knows so much. Now, Jordan, here comes a tough question. Can 27 be divided by 9?
Yes, it can.
I love it.
Excellent job.
Yeah, I love it. 3 times.
job.
That means if you took 9 and divided it into 7,893, here's your big shot. Would that be divisible by 9? Yes or no?
Well, I can't hear you.
I can hear me. Can't you hear me? I'm saying if 27, we added up all the digits and we got the 27 there, and we said, yes, 9 divides into 27. Will 9 divide into 7,893, the original number?
So 9 divided by 27.
Yes, it works.
9 can go into 27 how many times?
3.
It goes in 3 times. So it is divisible. 9 can go into 27. Mr. Herman's question is,
will it work on
the larger number?
The original number. If it works
That's
here.
hard.
Okay, well, Jordan is not meant to be hard. Mr. Herman is trying to show you a trick. if you add all of these numbers up together, it will
Thank
give
you.
you the 27.
Right.
And which means the 9 will go into the 27 as well as this large number, 7,893.
Wait, so 30?
Well, what we're saying is you're right. It does divide the
The
27
divisibility
3
rule
times,
does work.
and it does divide into here. So if I had a calculator real fast, I would go like this. 7,893 divided by 9, and guess what? It would go in evenly with no what?
Remainders.
That's it, no remainders. Can we get Jordan's name into
Jordan's name is right here, and it's going into the
I
treasure
love
chest.
my man Jordan. And do you want to try a challenge problem
Jordan,
today?
did you want to try a challenge?
No, I do not.
Okay.
Okay, Jordan. Well, at least you have your mind made up about that. But watch the rest of the show to see if you pull your name out of the treasure chest.
What?
Watch the show for the next 15 minutes so that you can see if your name comes out of the treasure chest. Okay?
Okay.
All right. It was nice
job,
talking to
Jordan.
you.
I'll see you tomorrow in the hallways.
Shout out to my family. Hashtag Jordan.
Okay.
Good to have pride in your family at all times. Okay.
All right. So, Mr. Herman,
Yes, ma'am.
we don't have any callers.
That's unbelievable. I can't believe we had 45 minutes of great callers, and now they're going to just not talk to
Yes.
us anymore?
I don't
Is that
like
how
this.
it is?
This is hurting
Was it
my
something we
feelings.
said to you?
And I know some of my students are watching me right now if they're not at the basketball
Well, I'm
game.
disappointed.
Some of my students went to the basketball game. Did you have a basketball game tonight?
No, I had no basketball game to go to.
Oh, okay.
They should be sitting by their phones
Well,
calling us up.
They need to call us at 301-772-0080. When we
Absolutely.
came back from the break, we did not go over the 24 challenge.
Absolutely. Let's go over 24
So
challenge.
let's go over 24 challenge.
I'll help you.
Okay, and what we have here are cards where we have to use all 4 of the numbers
Oh, yes.
using any combination of operations, addition, subtraction, multiplication, and division.
What is card A?
Card A is a 9. You told me that. A 9 because it's bubbled in, red. 4, 8, and 5.
And card B is 3, 3, 8, 7.
And card C is 8, 7, 2, 4.
And card D is 3, 4, 7, 7.
And card D is the hardest card that we have.
How do we know that? How do you know
because
that?
it has the 3 dots.
Oh, yes.
And this is a medium card because they have the 2 dots.
And don't you know while you're going over that great 24 challenge that Miss Arjane called you
Arjane
back?
called me back.
Oh, she loves talking to you.
She loves me.
Oh, that's great. Doesn't everybody? Okay, let's go back to Miss McCants and Arjane's show.
Arjane, this is our show. This is me and you, okay?
Okay.
The Gwen
All right,
Park Middle
keep
Show.
it coming, girl. Me and you. We represent for Gwen Park.
Okay.
Great. That's great. I feel good about that.
So what's your question, Arjane? Thank you for calling back. What's your question?
-10
-10
plus
plus
+24.
a positive 24. So Arjane, what's the rule when we're adding? Do we subtract or do we add?
Subtract.
We subtract. So I'm looking at 24 and 10. What's 24 minus 10?
14. 14.
14. Now, which one has the greater absolute value, the 10 or the 24? Which one is the furthest away from 0?
24.
24, so that means 14 is going to be
Positive.
positive. Arjane, you are on fire today. Mr. Herman, was there something that you wanted to add?
Well, you're a mind reader too, because that was just beautiful how you said absolute value. But right after Miss McCann said absolute value, she mentioned the farthest away from 0. That's what absolute value is all about. You gave a definition. Between you and Arjane, we have a team going on.
We have a team. And Mr. Herman, I wouldn't be here without you.
Well, that's why I'm here next to you.
Okay, so...
And is Arjane going to do a
Arjane,
challenge?
did you want to try a challenge now?
Yes.
Okay, which one would you like to try?
Now.
That's
look at
right.
her go.
Which one would you like to try, Arjane?
24 challenge.
Which one? Card A, card B, card C, or D?
Card A.
Card A with
Let me
9,
get those numbers for you.
4,
I'll write
8,
them down.
and 5.
9, 4, 8, and 5. And now Miss McCants and Arjane.
Uh-oh, Zoe called back.
Oh, I can't wait for that one.
All right. So we have 9, 4, 8, and 5. What would you like to do with these numbers? Which one would you like to use first?
Add.
Add what?
9 plus 4.
You're going to add 9 plus 4.
I better get her name ready. She might be going in again.
How much is 9 plus 4?
13.
Okay, so we've used the 9 and the 4.
Plus 5.
Plus 5 equals how much?
18.
18.
Plus 8.
18 plus 8 equals how much?
26.
26. Oh, you were so close.
Right. That's not,
we're trying to get 24.
Geez, I feel bad for her.
But
She
we didn't
tried
get
hard.
it. You want to try to give us a call back? Work on it a little bit and try to give us a call back?
Okay.
Okay. Thank you for calling
Great
and trying the
job. Good
24
try.
challenge.
I'm proud of our students. Come on. She didn't try it the first time. Now she gave it all
came
she
back
could.
and tried it again. Thank you for
Right.
calling, Arjuna. I'll see you tomorrow.
Next caller out there. Who could it be?
Who could it be? Who could it be?
I can see.
Who can you
in
see?
the crystal ball. I think it's Zoe.
Zoe, is that you?
Zoe?
Oh, it's Khadijah. You know Khadijah. We knew it was you, Khadijah, the whole time. We were just joking.
Khadijah.
We were just joking.
I'm sorry, Khadijah.
Khadijah, but don't give us
disrespectful.
attitude because we didn't mean it.
You know what? My crystal ball is a little fuzzy.
It was fuzzy.
I gotta get some cleaner,
we gotta clean
some
that,
glass cleaner, and
'cause
clean
we don't
it up.
like making mistakes.
It's all fuzzy and messed up.
Yeah. So, Khadijah, what's your question? You want to do the challenge?
Yes, I wanted to do the 24 challenge.
Okay.
Okay. Which one would you like to try, Khadijah? You want to write the number?
I'll write numbers down for you again. Absolutely.
B.
You want to try card B?
As in big.
As in boy?
Yes.
So that's 3, 3, 8, 7, or as in bacon?
Bacon. I put a 7 with a little slash so it wouldn't get mixed up with a 1 or something like that.
So, Khadijah, let's hear it. What do you have?
3 times 3.
3 times 3?
Yes.
Okay, and what did you get?
9.
Okay.
And then
Because there's
plus 8.
over there. My teeth falling out.
And then what did you say?
Plus 8.
9 plus 8. So we use the 3, and the 8. And how much is that?
17.
How much?
17.
17. And now what?
Plus 7.
17 plus 7. What is that?
I don't think that's
24.
24. Ring that bell.
Oh my
Khadijah
goodness.
got it.
Khadijah is in the house.
Khadijah got that 24.
In the little tiny treasure chest, too. Oh, my goodness.
So your name is going in the treasure chest one more time, Khadijah.
Way to call back and get yourself in there.
And I'm going to put
and
a
increase
smiley
your
face
chances.
for you.
I love
Yay.
it. There she is. We got a full box.
Yeah, we
And
got a lot of callers.
We got a full house. Let's go to our next
full
caller. I hope
house.
and pray it's Zoe this time. Is Zoe back there?
Zoe.
Zoe?
Zoe?
Hold on.
Hi. You called us back.
That's Zoe. Zoe! She's back! Yay! What can we do for you, Zoe? What kind of problem you have? I hope it's going to be multiplication, fractions, or what?
It's 12 times 9.
12 times
Well,
1
don't get
or
angry
12
about it,
times
Zoe.
9?
It was just a problem. Don't get upset.
12 times 1 or 12 times 9?
I thought you said 9.
12 times 9.
Okay, 12
Yes, ma'am.
times 9.
Whatever
Is it okay
you
that I wrote
say.
it like this?
Zoe, show off your multiplication skills to the whole world.
Is it okay that I wrote it like this?
It's 18.
Okay, 9 times 2 is 18. And what do we do with that 1?
What to laugh about?
We put it over top of the other one.
Excellent
I
job.
love Zoe. She's so clear.
So now we have 9 times 1 is how much?
9.
Plus 1.
10.
10.
And how do you say that answer?
108.
108.
Did I hear an and? Zoe? I know where you learn.
And he knows who your teacher is.
Yeah.
So it's 108 as your final answer, right?
Yes.
Do you want to try a challenge? I get your name in again. 24 challenge?
Did you want to try a challenge?
Yes.
Is that a yes?
Yes.
Okay, which one would you like to try? Card A, B, C, or D?
The D.
D is in dog. That's the hardest one up here. I know Zoe
All right,
can
she's
do it.
up for the challenge. 7-7-3-4.
Well put. Up for the challenge. I like
She's
that.
up for the challenge.
Up for the challenge.
Okay, Zoe, let's hear what you got for us.
Up for the challenge. Not down for the count. Up for the challenge. You can always count on us. But we're counting seconds and minutes here.
7.
Uh-huh. Ooh,
Good
I
start.
figured it out.
Good start.
Times.
Times.
Times. Oh. Huh.
Okay, 7 times.
7.
7, uh-huh.
Wow. I don't know.
Is 49.
49.
Oh my goodness,
Look at
that's
this
great.
mathematician.
She knows her stuff.
Mm-hmm.
But now, Zoe, oh, thank you, Miss McCants.
Mm-hmm.
Now the 7s are gone. What are you going to do with the 3, 4?
49 plus 3.
49 plus 3. Mm-hmm. What's 9 plus 3?
12.
What's 1 plus 4?
5.
Okay, now what?
We're going to do with the 4.
52 plus 4.
What does that give you?
Remember, Zoe, we're trying to get to 24. We're trying to get to 24. Is this going to give us 24? What's 2 plus?
No.
Yeah, it's too big.
56. But at least she tried her best. That's the hardest one there. It has 3
very
dots.
hard. Yeah, it was very hard. Zoe, why don't you try to work that out and call us on Wednesday? Because I don't think we're going to have enough time for you to call us back.
Okay.
So call us back on Wednesday.
Pleasure to have you back on the show again. Do we have time for one more caller?
I think
Tongwa?
we
Tongwa?
have from New Carrollton.
And we're going to work this one fast. Tongwa, you're on the
Tongwa,
air.
are you there?
Go ahead. Give us your fraction problem.
Hello? Tongwa? Tongwa, are you there?
I think something got cut off.
Yeah, I think
Like she
so,
dropped
too.
the phone or something.
Mm-hmm.
Well, as you already know, people,
Mhm.
this is your favorite math show of the nation,
Mhm.
and we're going all over Prince George's Community
That's right.
College area, Prince
Prince George's County. We're all over Prince George's County.
And I think we go other places too.
And we want all of the callers from middle school and elementary to give us a call during our show, right?
Absolutely.
And they can call from 4 to 5 on Mondays and Wednesdays for elementary,
Mhm.
and 5 to 6 on Mondays and Wednesdays for middle school.
And we're on this Wednesday. We're on this Wednesday too, the show.
The show is on
And you
this
know what,
Wednesday.
Mr. Kent, I got to tell you straight up to your face.
Mhm.
You are so lovely and
Aw,
brilliant
that is
with your
so nice of
ability,
you to
your
say.
high
Let me
ability
close
for
my
teaching our kids such good math. You get to pick our strongest winner out of the group.
And let me see.
And who could it be today? I'm anxious to see this one.
It's Julian.
Julian
is the
from
winner.
Hyattsville Elementary. Julian, Hyattsville
Congratulations,
Elementary.
Julian.
We have to thank all our callers for calling in. And there's always one thing you should remember in your head. You can always count on us. Yeah.